Okay, if you can write that down, that's what we're doing next now. Okay, question?
How do we pronounce the last name?
Motion?
No, how do we pronounce your last name?
Oh. That makes more sense. Easily Welch. Yeah. Yeah, so I thought you were asking me how to pronounce motion. Alright, continue?
Yes.
Yep. So, a few equations to look at. Anyways, uniformly accelerate linear motion, what does that mean? Well, I think you all know the word uniformly. What does that mean?
Just.
Constant. And accelerated, constant acceleration. So this means the acceleration is not changing. Right? So, uniformly accelerated linear motion is motion which is, number one, in a straight line. Now, why am I saying it's in a straight line? Because of the word linear. Has a constant acceleration. Why am I saying that? Uniformly accelerated. Okay, and this is a very common motion in physics. It's very common. So this is why we have a whole lesson on it. Okay, just write that definition down. Okie dokie. You guys got that?
No.
Not yet. Yeah? Continue?
Yeah.
Yep. Okay. If you were to graph this on a velocity time graph, it would look like a straight line, wouldn't it? So, let's see what equations we can make. Oh, and before I continue, the proof of these equations could be asked of you in the exam. However, I don't think they will ask it because it's kind of long, it'll take too much time and so on. But according to the syllabus, they could ask you this proof in the exam. It's just they never have over the last 10 years. So I still think it's good to know the proof just in case they ask you. These proofs are on the exam, technically. Okay, so let's look at the proof. Question, yeah?
What exam are you talking about?
Well,
Because you always say the exam, not like your exam. So yeah, maybe I know you want certain questions.
oh, I see. So you want, yeah, who writes the exam?
Yeah.
The exam is written by Manchester University, and they send it to us. So I don't know what's on the exam until you see the exam. But we have lots of past exams we can look at for guidance. They've never asked this in the exam, okay? but they could because it's on the syllabus. Okay. Right, so let's have a look at the proofs. The first proof will use, the first rule, the first formula, will use the distance, speed, time triangle. Okay. I'll just say DST triangle. Now we have a small problem. I said, well, according to this triangle, distance equals speed multiply time. Times time, yeah. Okay, we could say the distance is probably like the S. I mean, but we have a problem. We have two speeds. We have a U and we have a V. So which do we use? Because I said we can only use one speed, a constant speed. Do we use U? Do we use V? Not V.
U.
Not U.
They're different.
V minus U. Good try, but no. So, in physics, there's a common trick. If you can only use a constant value, but the value changes between U and V, you use the average. You're allowed to do this in physics. So if I have a formula that needs a constant, but instead of a constant I have two values, then I can use the average. Yeah, which is going to be U plus V over 2. The average. Multiply T. That's our first formula and our first proof. And we call that formula number 0. And the reason it's called 0 is the formula is so basic from the definition that it doesn't deserve to be called number 1. Okay, true. So I'll call this formula 0. Right, that's our first proof. Can you write that down? And we'll do the next one. There are 4 in total.
So the S is represented like distance.
It actually represents displacement.
Oh, displacement. Okay.
Yeah. Even though in the triangle it was a distance originally. Multiply, yeah. Yeah. Right, the next the next formula that we'll do is if we have our graph and this is U and this is V and this is T. Remember we said the acceleration is the slope. Or also, we also said it's the change in velocity over change in time. Whatever way you think about it. That's equal to V minus U over T minus 0. We can rewrite that as AT equals V minus U, which means V equals U plus AT. I'll just put this in a box. This is our next formula, formula 1. Okay, you got that? Yeah? Okay, can I scroll down?
Yes.
Yeah. So now the next proof, what we'll do is we'll sub 1 into 0. So we have, sorry, I said that backwards, I'm sorry. Sub Yeah, no, sub 1 into 0. So S equals U plus V over 2 multiply T, but V equals U plus AT. So I can say S equals U plus AT over 2 times T. So S equals 2U plus AT over 2 times T. That will be equal to U plus a half AT times T. So finally that's S equals UT plus a half A T squared. That's equation 2. Yeah? Okay, tell me when you have that, and then we can look at the last formula. Yeah? Okay. I can scroll down?
Yes.
Yeah. So the next one, we can sub, what numbers, sorry, I think it's number 1 into 0, yeah. Really? Yes, it's the same, but a different way. so sub 1 into 0. So S equals U plus V over 2 times T. And we have V equals U plus AT. And this means that T equals V minus U over A. And I'll sub that in this time. So now you have S equals U plus V over 2 times V minus U over A. So that means you have 2AS equals UV minus U squared plus V squared minus UV when you expand. These cancel, and you can take this to the left, and you get V squared equals U squared plus 2AS. And this is equation 3.
There are 5 equations, right?
4. Okay, you got that?
Yeah.
So it's like
Okay. Got it? Yeah? Okay. So to summarize, we have S equals U plus V over 2T, V equals U plus AT, S equals UT plus a half AT squared, and V squared equals U squared plus 2AS. We've proven them. Yeah?
Yeah.
Okay. To solve any problem we require to know at least 3 of the 5. So, for example, if you know UVA, you can get TS. You need to know at least 3. Okay. These problems are often called SUVAC problems or UVATS problems. I usually call them UVATS problems. But in some books you might see them called SUVAC problems. Or kinematic equations. Now, we'll need to have a look at some examples to make use of these formulas. You don't need to write anything down here, it's okay, there's nothing important here. Let's have a look at our first example now. So, a girl is about to start cycling her bicycle. She's at rest and cycles to 9 meters per second in a time of 6 seconds. Right, together now, together you can tell me what UVATS is. So, what's the first piece of information I give you?
Just that's from rest.
So what does that mean?
U
is 0. And what do we know next? V is 9. And what do we know next? Time is 6. Yeah. First I want to know how far did she cycle. I want S. Right, look at the formulas I gave you. Which one could give me S if I have U, V and T?
0. First one.
Yeah. You can say S equals U plus V over 2 multiply T. So S equals 0 plus 9 over 2 times 6, which is 27. So the answer for S is 27 meters. What was her acceleration? What formula should I use to get the A? V equals U plus AT. 9 equals 0 plus A times 6, isn't it? So A equals 1.5. Okay? Right, write that down. That's our first example.
If we use like A equals delta V or delta T.
That's okay. Delta V over delta T?
Yeah.
Yeah, that's fine. That's like using the Formula 1 anyways. Yeah?
Yeah.
I think you've all seen these formulas before if you've done physics, right? Really? Not all of them?
But probably a different way, like we're using like V0 or V1.
Yeah. Yeah. Do you still use A and S?
Yes. Right.
So you would have V1 equals V0 plus AT.
Yeah. Or you can
And you have
No,
V1
zero.
squared, what do you use?
1, 2. We don't
Oh,
use
1, 2.
zero.
Okay. So you'd have V2 squared equals V1 squared plus 2AS.
Yeah.
Yeah. Or if American system, VF equals VI plus AT.
yes, we also use.
Use this one, yeah, okay. Right, continue? Yep. Okay. Before I give you the answer, I think I'll let you try it. A car is traveling at 120 kilometers per hour. So you need to change that into meters per second. The driver sees a crash up ahead and suddenly brakes. According to the RSA, it will take 100 meters to bring the car to rest at this speed. What is the acceleration of the car? And how long did it take for the car to come to rest? So you understand what's happening? The car is going 120, then the driver suddenly stops. Takes 100 meters to stop the car. What's the acceleration and what's the time? Okay, I'll give you a minute to try it, then we'll do it together. See if you can get it. I think you can. You remember how to change kilometers per hour
Yeah.
into meters per second? Yeah.
Times 5 over 8.
Oh, I don't like it this way.
Why?
No, no, no. Don't like it this way. Do it the way I showed you.
Fastest way.
Yeah, but it's a dangerous way. I think we got the answer. You think you have it?
Yeah.
Yeah? Let's have a look. Well, I still see you working. You're finished as well? Yeah, not yet?
How would we get the formula sheet in the exam?
Okay. Let's have a look. So, firstly, the U, which is 120 kilometers per hour, will be 120,000 meters over 3,600 seconds. Can someone tell me what that is, please? If 0, 1, 2, 3. What is it?
33
Yeah. Okay, the V, 0. The A, don't know. T, don't know, S,
Yes.
100 meters. And what did I want first? The A?
Yes.
So we can say V equals U plus, oh, no, not that one. V squared. V squared equals U squared
Plus 2AS.
plus 2AS, 200A.
Yeah.
So A will be minus 33.33 squared over 200. So what's that? Minus, it's all the fives, is it? 5.54. What's after the 4? 554. So A is minus 5.55 meters per second. And to get the T, we can say V equals U plus A T. So the T is 33.33 over 5.554. And what's that, please? About 6 seconds, 6.00.
6.0.
Yeah. Yeah.
How is V0?
Say again?
How is V0?
Because it's stopping. It's coming to rest. Yeah? He puts his foot on the brakes and brings the car to rest. So it's 0 at the end. Okie dokie.
Should I must write C point 00 or just C? The C is okay.
I think it is good to write 6.00.
Oh,
Yeah.
But then no
No.
to tell you write 3.
No, for the physics exam, all the answers must be true.
Oh,
Okay?
okay.
Teacher, try change to the 100 meter to the 0.1 kilometer.
No, I recommend you convert everything to meters.
Meters.
But yeah, from this way around. Because then what happens is your acceleration will be kilometers.
Yeah.
It's not usual. Okay, continue. Yeah. So, here's another one for you to try. A ball is dropped from the top of a building. It's dropped from rest. It's 25 meters high. It takes 2.26 seconds for it to hit the ground. What was the acceleration and what is the speed when it hits the ground? Okay, try this one now. Let's see if we can do this. Okay, you should be finished that one now. Let's have a look. Okay, what's the U here? 0. The V we don't know. The A we don't know. The T
2.26.
and the S? Yeah, but I prefer to say minus 25 because in my picture, if this here is the starting point, then the ball has fallen 100 meters. I want to make it clear that it's dropped 100 meters, not risen 100 meters. Okay, so really you should say minus 25. How can I get the A? What formula?
We can know that acceleration for drawing.
We can find it.
We don't know the X, I didn't tell you. Which formula? Yeah. S equals UT plus a half A T squared. So the A here is it's minus 50 over 2.26 squared. What's that? 9.789. So 79. Yeah? No, it's not actually, it's a little less. What else do I want? Oh, the V. So V equals U plus A T. Okay, so what do you get here? 22? Now that's the V, but I actually said how fast I wanted the speed. So what's the speed? Yeah. The positive of it.
Oh,
Yeah. Because I said how fast. That means in English the speed, not the velocity.
okay.
If anyone asks you how fast, they always mean speed, not velocity. Yeah, is that clear? Yeah. What's that?
Okay, what if you make use of a distance time graph?
It's fine. It's fine. Totally fine, yeah.
But when I used that, I didn't get the same.
What did you get?
I got 11.
That means you made a mistake. So what did you say the A was in your calculation? What over what?
That's delta y over delta x.
And what did you say delta X was?
2.26.
And the delta Y?
25.
And how'd you get 25?
That means distance.
Yeah, but what's on the Y axis on those graphs?
That's 25.
No. No, it's not.
I said distance time graph.
Oh, a distance time graph. Okay, fine. We don't usually use those, but we can. Okay. But then on a distance time graph, the slope isn't the acceleration. The slope is only the acceleration on a velocity time graph. So this is why it didn't work then. But you could use a velocity time graph. That would be fine.
But we don't have the.
In fact, do you know what the slope on a distance time graph does represent?
No.
It's the speed. So your slope isn't the acceleration. That's, okay, continue. Right, so if you drop a ball here, it will increase its speed by about 10 meters per second each second. Roughly the acceleration is a 10. Now in this example here it wasn't a 10, it was roughly 9.8. In fact, does anybody know what the acceleration is when you drop something? 9.81. So meters per second squared. So for this course, the acceleration due to gravity, we call that a g, and we say g is 9.81. Now, I think in China they use 10, right?
No, 9.8.
If
9.8.
Yes.
if the questions will not tell you G is equal to 10, you will use
9.8.
9.8.
Okay.
Yeah.
Okay, but sometimes the question says use 10.
No,
No,
always
it's not 9.8.
Okay.
Because they want the calculation become more difficult.
Yeah, 'cause it's no calculator.
Because you hope to do that. They hope to do that.
What did you use in school?
9.81, but the question said use 10.
Okay.
Sometimes.
Sometimes.
Yeah. For you, Danny? Do you remember?
So when in junior school 10, senior school 9. But
8. Yeah, that's normal too. Okay, so please make note of that value. On this course we use 9.81. You got that? No. English. Okay, continue.
Wait a second.
Okay. Marwan,
Okay.
right? Just because I'm your teacher doesn't mean I'll slap you if you keep using Arabic, okay? You don't know what Irish teachers are like when they get angry. Right? Okay, you have that?
Yeah.
Yeah? Right. Continue?
Yeah.
Yeah.
Right, a ball is thrown vertically upwards at a speed of 50. It leaves at a height of 1, travels up, stops, falls back to earth. So I'll just draw a picture here of what's happening. So it starts here. It goes up, stops, and then comes back down and hits the ground here. Okay? This distance, I tell you, is 1 meter. And it's thrown up with a speed of 50 meters per second. Okay? And that's all. The other information you know is the acceleration is minus g. That's the acceleration, which is, a equals minus g, which equals minus 9.81 meters per second squared. Okay, so you have 3 pieces of information. I'm going to let you try this. It's a little hard, but it's something you could get in the exam. I'll give you a minute to try it, and then I'll give you the answer. Let's see if you can do it. The first question is the maximum height. I want to know this distance. That's the first question. Okay. And my hint is it stops. So the ball here is at rest at the top. If you picture it, it goes up, slows down, stops, then falls back down. Yeah, it stops, yes. It's true. It's true, yes, believe me, it stops. It goes up, it slows down, stops, and then falls back down. Okay, you can trust me. All right. Now, here's the information. You can try it. 50 is the U.
Yeah.
So what do you mean by falls back to
So in the picture, the ball falls back to the earth rather than to her hand.
but you still mentioned that it hits the ground.
Yeah, yeah, hits the ground here.
No, like I mean in the question, they said it falls back to earth and then it hits the ground. So like when it fell back to earth, where was it?
Right, say that again. What are you asking me?
Okay, so it was stated that then the ball falls back to earth and then she allows it to fall on the floor.
Yes.
So
Yeah.
which means it was somewhere before she allowed it to fall on the floor.
What do you mean? So it goes. It's like it starts here, a meter above the ground, and she throws it up, and it hits the.
Okay, what I'm saying is that okay, if it falls back to earth, that means they were not meant to include the last sentence.
No, you should include it because it. If I say it falls back to earth, it could fall back to earth and fall into her hand.
Okay.
So I get what you're saying. Do I really need the last sentence? Yeah, I do, to be clear. And I think, Dami, in the exam they would say that too, in the question.
Velocity is not uniform.
Yeah, the velocity's changing. There's a U and a B. Is that what you mean? Yeah. Son. Don't make me angry now. English only.
Answer all question.
Hmm?
Answer all question.
If you can. But we can get started on doing it now. Did you get the first part?
Yeah.
You don't sound sure.
Does not look logical.
No, it doesn't. What did you get for the first part?
127 meters.
Well, that seems okay.
It's pretty strong.
Yep.
And
Yep, it is. Sure is. Yep. All right, let's have a look. So, for the first part, what's the U? 50. The V? 0. The A? minus 9.81. The t, don't know, and the s, don't know. And the s is what we want. What formula could I use here? V squared? V squared equals u squared plus 2a s. Isn't that right? S equals 2500 over 19.62. What's that? 2500 over 19.62.
One,
Nine.
127.
This is 127.4.
4, yeah.
So that's 127 meters. So the maximum height is 128. Isn't it? Because it starts here. Yeah. Right. How long until the ball hits the ground? Okay, let's do that part. U, 50. V, don't know.
Yeah.
For the second part. A, minus 9.81. T, don't know. That's what we want. And S, S you do know. What's S? Nope. Nope. What is it? Nearly, but no. Nope.
Back to the question.
What's the S? There you go. The S is minus 1. Isn't it? What's the displacement here? Yeah, yeah, obvious now. S is minus 1. Because, what do you mean how? I just drew it there.
So that's going down.
1 meter below where it started. That's the S. Starts here. And it's 1 meter below where it started. That's the S.
So the origin is what?
The origin is our hand. That's where the story begins. Yeah? Look, if this is the origin, and this is 1 meter off the ground, and I drop something on the ground, how far away is it compared to the origin? 1 meter, plus or minus. Why minus?
Just going down.
It's down. What would be, when you first told me S equals 1 meter, where would that be? That would be like here, a meter above the origin. Right? So it has to be minus 1. What formula should I use here? S, I forgot what I'm looking for. T, isn't it? S equals U,
UT plus
T,
half.
a half A, T squared. So you get 4.905 T squared minus 50T, if I take everything to the left, minus 1 equals 0. Now, did you learn how to solve these equations yet in maths class? Yeah, what type of equation is this? Oh yeah, I'm your maths teacher, haven't I? Right. What's the last lesson we did? Surds. Oh, we learned how to factorize this, but we can't factorize this one because it has decimals. Yeah, you have to use the formula. So, I'll use the calculator, but next week we'll see how to do it properly. The formula, yeah, there's a formula here, but there's even a better way on the calculator. Look, this is A, this is B, and this is C, and this is called a quadratic. And I want the T. Yeah, now there's a nice way to do this on the calculator. Oh, you've typed it in already, have you? Yeah. Yeah, this formula. Yeah. for AC. Yeah. But there's an even quicker way. You can type mode 53.
But I don't have
Ah, well, I'm sorry you have such a lame calculator. That, and that.
Yeah.
Wow.
Yeah. Wow.
Power of calculator.
Indeed, the power of calculators. 10.21 seconds.
Yeah.
And if you have the calculator I recommended, you can solve this by using mode 53 on the calculator. But don't worry, we'll do this more in maths class.
Sometimes you have two answers.
Yeah, the second answer is silly.
this one negative.
Yeah.
Where?
Where what? Mode
Oh.
53.
53.
Well, it might be different on that calculator. Let's see. Mode. Oh my goodness.
Shapes.
Yeah.
Teacher, you tell me the great calculator.
Yeah.
Oh, no. I don't have this.
Yeah, you should use this.
No, not on that one. Not on that one.
These like advanced
Yeah. Exact on the channel.
Here you go.
Okay. Thank you.
All right.
If we split the question into two, if we can't give the time to give up, then
There's always someone who asks me this question, and the answer is yes, you can do this, and I know I don't like it.
yeah, but like you will be zero, so we won't have a quadratic. So like, you will take.
That's true.
Yeah.
That's true, but I have a powerful calculator, so it's okay. Right, next. I think you already know the next part. How far does the ball travel? How far does it travel? Yeah, well, it'll be 128.
That's 1.7.
No. It'll be 127 plus 127 plus 1. Yeah, 255. Okay, that's part C. How fast is the ball going when it hits the ground? How fast?
Velocity.
That's the V here. How can I get that V? What formula? V equals...
Really?
No. Easier one.
U plus
U
H.
plus
G.
AT. What's that?
Negative 50 with answers.
So what's the speed?
50 with answers.
51.
Okay, and finally, the last part. What was the average speed? And I give you a hint. The average speed is the total distance over total time. So average speed, what's the total distance?
255.
And the total time?
10.2.
10.21. So
25.
what is it?
25.
That's the average speed. Okay. Yeah?
How did you get to second 127?
Ah, yeah, so it goes up 127, down 127, and then an extra meter. That's its journey. Throw the ball up, down, and then a little more. In the picture at the start, she throws it up, down, and then hits the ground. So that's why the 127 appears twice. That's 127, that's 127, and that's 1 meter. Yeah? What?
No.
Now come on, be good. Okay. Did you get this fully right? No, not really, no. So write this down carefully. Do you need the first part too? Or do you have the first part? Well, can you still see all of this?
Yes.
This is A, B, C, D, E. Okay, write this down. Now, there's one more question I want to give you after you write this down. Okay, you have this all written down?
I think it's in some.
No, that was more, I don't know,
Teacher,
dramatic pause, I guess.
can you tell me how can I back to the
Yeah, okay, yeah. Mode,
This is important.
it is important, yeah. So look,
Oh.
you just pick menu, okay? And you
Okay.
press equal for enter. So the normal mode is number 1, okay? So what I picked earlier for you, I think it was called, maybe it was functions or something, I can't find it. Equations, I think it was. And then I picked the second one, called polynomial. And then I picked 2 for quadratic, 3 for cubic.
Okay.
But anyways, I'll go back to the first one. The normal mode is this one.
Okay.
Okay, there you
I
go.
need a number one.
Yeah, yeah.
I want to see the question.
You want to see the question? Sure.
Yeah.
It's okay, but it's not the best.
Which one?
Casio 991.
Oh, 991.
EX or ES.
I don't think it matters too much. They do the same functions. Yeah.
Sorry, can you go over B again?
What do you mean?
Can you just repeat?
I can't because I don't quite have the time because I want to go on to the next question. But this is all recorded. You can watch it again on YouTube.
Okay,
Yeah.
but I thought like is the
Is there a particular part that's confusing? Yeah.
Is it supposed to be V squared or like the formula?
Oh, sorry. Yeah, the formula I used. Yeah, I used this one. S equals UT plus a half AT squared. Yeah, yeah, yeah. Because if it was V squared, then there shouldn't be a minus. Yeah. Yeah. Go ahead. Okay. Do you have that? Yeah. Can I scroll down?
Yeah.
Okay. I'm going to give you a hard one here. So here's the story. Yeah. Here's the story. What's happening? We got a straight road here. 100 meters. Okay. A, B. And we have a car here. And a car here. And we'll have this one starts at 20 meters per second. Okay. And this one here would say starts at 10 meters per second. And this one has an acceleration of 1 meter per second squared. And this one is accelerating to the left, which will say 2 meters per second squared. And my question is, where do they meet?
Is the speed towards the right or the left of the wheel?
Yeah, sorry, this is heading to the left at 10, and this is heading to the right at 20.
Sorry, this
Yeah.
kind of question, does the acceleration due to gravity affect them?
No, it's just horizontal ground. Huh? Not necessarily. If it does, it's only by accident. I just pick the numbers randomly. I wouldn't expect it to meet at the midpoint necessarily. Because the speeds are different, you know? And the accelerations are different. Don't know. You'll find out. Yeah. Oh, go on. Go on quickly.
Nothing good.
What?
per second is until to the 0, or is until 0 is 20 meter.
U is the 20 meters per second. And the A is 1.
A is 1.
Yeah, so its speed will never be 0. Ming, what you checking? Dictionary?
The equation.
Oh, the equations?
The equation.
Ah, you have all the equations.
How about the equations?
Okay. Anyone feel they were successful? Peter. No, Peter, yes. Jason. Jason.
Yeah.
Think you got it?
Huh?
Think you got the answer?
Not yet.
Not yet, okay. You think you might get the answer?
I think.
Okay. Ming? Okay. Let's have a look. So let's look at car A. Tell me, how far has car A travelled? Let's call it SA. That will be UT, yeah? What's the U? 20. T plus a half A T squared. Yeah? Right. How far does car B travel? 10T plus 2T squared. Yeah? But what do we know about SA and SB?
100 meters.
Yeah, well, I would just say SA plus SB equals 100. Because if they meet here, then SA and SB must add up to 100. So we have 20T plus a half T squared equals plus 10T plus T squared should equal 100. 3 over 2T squared plus 30T, yeah, minus 100 equals 0. Let's multiply by 2. 3T squared plus 60T minus 200 equals 0. Calculator time. Mode 53. 2.91 seconds. So here I have T is 2.91 seconds. But that's not what I asked. I asked where. So you can put that in here, or you can put it in here. So if I put it into this one, what do I get? (37.6 meters). So they meet 37.6 meters from B. Okay, or you could say it the other way around.
100 minus.
Yeah, 100 minus. You could also say 62.4 from A. Okay. Okay. I think you might need to write that down unless some of you got it. You got it written down?
Mm-hmm.
Not yet? Who's
In the exam, just write me.
one of them's enough, yeah.
Okay.
Okay, you got that?
If we like consider A as the origin, like make B negative.
Yeah. The other way you can do this, if you like, is you can treat A as the origin, and then B here would have negative values. However, the formula for S would not quite be the same. Because B is not at the origin, then for this one here, okay, so I get what you're saying. You could say SA could equal 20t plus a half t squared as normal, and then SB
100
would be,
plus
you'd have to add on 100, correct? It'd be 100,
minus
and then minus 10t minus t squared. And then you wouldn't say plus SB equals 100. What would you say? SA equals SB. Yeah, that's fine. But you'll get the same answer. Yeah. Okay, did you write that down? Yeah. So what we'll do is, there isn't really the time to start the next lesson, so I'll give you this time to get a start on your homework. You can appreciate that this is a very important topic in mechanics, because these formulas are very common and are used a lot. Okay, so how many questions do you have here? Probably a lot. Let's see. Only 7? Ah, no problem. Yeah, only 7. Well, there's only one lesson, not 2 lessons. Okay, get a start on those now, please. Let's do as many as you can. Maybe you'll get all 7 done. You never know. But maybe not. Ah, no, you'll get more than 1 done in the 15 minutes left.
Done.
Yeah, it's 15 minutes left.
The